Thank you, Louis. So, my talk is on critical information infrastructure protection and the relation to the future Internet. I would like to start with some definitions. Critical information infrastructures, which are information or communication systems whose incapacity or destruction would have a debilitating impact on the national security and the economy, as well as social well-being of a nation. Future Internet, which is a summarizing term for worldwide research activities dedicated to the further development of the original Internet. Resilience is defined as the ability of a system to provide and maintain an acceptable level of service in the face of various faults and challenges to normal operation. Availability, the extent to which a system is ready to be called into duty for its designated purpose without advanced knowledge of when this is needed. And robustness, which is the degree to which a system or component can function correctly in the presence of invalid inputs or stressful environment conditions. I would like also to try to define a system model for CIIP, where such a system consists of hardware, of course, which is the electronic and physical components that comprise the network nodes, including framework frames, circuits, etc. The software, where the computer codes, we have the computer codes that control our system. This category covers also all aspects of creating, maintaining, and protecting that code. Of course, the networks. Networks include the various topological configuration of nodes, synchronization, redundancy, physical and logical diversity. The payload, that's the purpose of a communication network. It is to deliver some form of communications, be it voice, data, or multimedia. The payload category includes the information transported across the infrastructure, of course. We have also power. Every information system needs power to operate. We have the environment where the information systems reside. This can be temperature-controlled rooms, or it can be outside in very difficult weather conditions. It can be the space where the satellites orbit. It can be the sea where cables reside. Excuse me. Anyway, we also have the humans who operate the systems, and their part is very critical in the operation of the entire system. And of course, some policy issues between entities, organizations that cooperate in our system model. And all this together, these 8 modules, form the communication infrastructure. On top of that, we have the critical applications that could be energy and electricity, banking or finance, law enforcement, water supply, government services, emergency and rescue services, health services, logistics, distribution, transportation, and whatever we might find that is critical. Considering the variety of tasks and responsibilities affiliated with CIIP, the first step is to define the essential priorities and responsibilities. These essential tasks of CIIP are arranged in a 4-pillar model. The 4 pillars are, first of all, prevention. The aim is to reduce the number of information security breaches. However, since security threats for critical infrastructures are manifold, also interdependent and complex, it is unrealistic to expect that incidents can be altogether prevented. A more realistic goal is to ensure that critical infrastructures are less vulnerable to disruptions. Any impairments that should be short in duration and limited in scale, and services